Hey guys, Brian here. Welcome to BARROGO Engineering Tutorial. I am Vance Brian BARROGO from BSCA2 of Cavite State University Main Campus, your engineering buddy to help you aid engineering problems. Like and subscribe to my channel for more engineering tutorials. In this video, I will discuss about the flight of projectiles, where air resistance is neglected, under the chapter of Curvilinear translation. So let's assume that the projectile to be moving without rotation in a vacuum. We will neglect all the factors that affect the actual flight of the projectile, such as the wind velocity, air resistance, and the rotation of the Earth. Let the path of the projectile will be given by the curve OBCD as shown in the figure, having the origin of the axis at the initial point of the flight. The initial velocity is taken as V sub O directed by an angle with the x-axis. So, the angle formed by the initial velocity and the x-axis will be represented by d sine theta. Distance x is the horizontal distance from the initial point of the flight up to the final point of the flight. Distance y is the vertical distance from the reference line up to the final point of the flight. Any vertical distances below the reference line will be considered as negative. In this problem, we have a situation that a projectile is being fired with an initial velocity of 60 meters per second, upward at an angle of 30 degrees to the horizontal from a point 80 meters above a level plane. What horizontal distance will it cover before it will strike the plane? So first, we will write the given. So our initial velocity is 16 meters per second. The angle theta is equal to 30 degrees. The vertical distance y is equal to 80 meters. And what is asked is to find the horizontal distance from the initial point of the projectile up to the final point of the projectile. In order to solve this problem, we will use the formula y is equal to x tan theta minus gx squared over 2v squared cosine squared theta. We will just substitute the given to the formula. Since that any vertical distances below the reference line will be considered as negative, our y here will become negative 80 equals x tan 30 degrees minus the gravity 9.81 multiplied to the unknown value of x squared over 2 multiplied to 60 meters per second squared cosine squared 30 degrees. We will just copy negative 80 here equals the value of tan 30 degrees is equal to 0.5774, and don't forget to copy the unknown value x minus the equation here will give you the value of 0.001817, and don't forget this x squared. So we will equate this equation to 0, and it will give you 0.001817 x squared minus 0.5774 x minus 80 equals 0. For us to solve for the value of x, we will use the quadratic formula. X is equal to negative b plus minus square root of b squared minus 4ac over 2a. So we will just substitute the terms here to the formula. So the first term will be the a, second term is the b, and the constant is the c. So x is equal to negative 0.5774 plus minus square root of negative 0.5774 squared minus 4 multiplied to 0.001817 and negative 80 all over 2 multiplied to 0.001817 0.1817. This equation will give you the positive value of 422.909 meters and negative 104.31. So since that there is no negative value for distance, so we will consider this as the distance from the initial point of the flight up to the final point of the flight. So our x here is equal to 422.09 meters. That's all for now. I hope you've learned from this video. Thank you for watching BARROGO Engineering Tutorial.